Good morning. So in the last class, we have discussed how to derive a unit hydrograph from the observed flood hydrograph and what are the assumptions or rather propositions of the unit hydrograph. And also we have discussed the limitations of unit hydrograph. So these things we have discussed in the last class. And we know how to derive a unit hydrograph from the observed hydrograph. And these are the assumptions or propositions of the unit hydrograph. That means the ordinates will be in proportion to the intensity of the rainfall. And also if you have a continuous storm, you can have many number of hydrographs, then you can combine these hydrographs, unit hydrographs by the method of superposition, then you will get a combined unit hydrograph if the area of the basin is large or if you have a continuous storm. And also the percentage of runoff at different time interval will be in the same proportion as the intensity of the rainfall. So these things we have discussed in the last class. Now we shall solve some numerical problems on unit hydrograph. Now the derivation of unit hydrograph. So let us have an example. The runoff data at a stream gauging station for a flood area are given below. The drainage area is 40 kilometers square and the duration of the rainfall is 3 hours. So derive the 3-hour unit hydrograph for the basin and plot the same. So now these are the data. Now the derivation of the unit hydrograph, 3-hour hydrograph. So this is the given problem. So here you have two dates, that is 1/3/1970 and 2/3/1970, and the time in hours are given 2, 5, 8, 11, 14, 17, 20, 23, and the second day also the interval is 3 hours because the duration of the storm is 3 hours. So we have taken 0 to 0 is also considered here. So 3, so it becomes starting with 2, 5, 8 intervals of 3 hours. And again, on the second day also, you have the 3-hour unit hydrograph, 3-hour duration storm. And these are the corresponding discharges measured in the stream. So these are the discharges in cumex. These are the discharges in cumex. Now, you have the discharge values here. Now you can see here, the peak discharge value is about 290. So the flood hydrograph has attained its peak at 17th hour on first day. So the peak of which is 290 cubics. Now we have to derive the unit hydrograph from the unit hydrograph for the 3-hour duration storm. And this is the table which shows how to derive a 3-hour unit hydrograph from the given total runoff hydrograph. Now these are the time interval. Time interval is given and the corresponding dates are given. Now you have to plot discharge, that is whatever the discharge value that you have here on these corresponding dates. You have to plot the total hydrograph. So once you plot the total hydrograph, then we need to measure the total runoff ordinates, that is TRO, and then you have to find out the ordinates of base flow. So that will be in the column 4, you have the ordinates of the base flow. Next, you want the direct runoff ordinates. So from the unit hydrograph definition, so the unit hydrograph is nothing but it is a hydrograph having unit duration which is occurring uniformly over the catchment area and which produces a volume of runoff is equal to 1 centimeter. Now here on two particular dates you have the time intervals in 3 hours, and when you plot the graph you will get the total runoff ordinates. These are the total runoff ordinates in column 3, and whatever the values that you have in column 4 are the base flow ordinates. Now if you deduct the base flow ordinates from the total runoff ordinates, that is 3 minus 4, you can see 3 minus 4, you will get the direct runoff ordinates. So these are the direct runoff ordinates. Column 5 values are the direct runoff ordinates. Now this direct runoff ordinates has to be divided by the net precipitation depth. the net precipitation depth in order to get the unit hydrograph ordinates. So now when you divide the direct runoff ordinates by the net precipitation depth, so you get the ordinates of the unit hydrograph, ordinates of the unit hydrograph. Now, so you can see here the unit hydrograph has a lag time of 3 hours, correct? Now here it is 2nd hour, 5th hour, and from 5th hour you have the zero of the unit hydrograph. So after that you have 3 hour interval unit hydrograph, 3 hour interval unit hydrograph. Now here when you add the sum of the direct runoff ordinates works out to be 986 cumex, and if you divide the direct runoff ordinates by the net precipitation depth will be got by dividing this sigma DRO ordinates by the area of the catchment. By the area of the catchment will give you the net precipitation depth. So when you get the net precipitation depth, you divide the ordinates of the direct runoff ordinates, that is whatever the values in column 5, divided by the net precipitation depth, you'll get the ordinates of the unit hydrograph. So now again we shall see here in the previous class we have discussed. Now you can see here the same problem you can see here. So on two particular dates, so here starting along the x-axis, the time has taken as 2. The axis, the origin of the coordinate axis itself is 2nd hour, then 5th hour, 8th hour, 11, 14, 17, 20, 23. So second day, again you have 2, 5, 8, 11, 14, 17, 20, 23. So now along the vertical axis, these are the discharge values in cumex. So maximum is, in our case, it is 290 cumex. 290 cumex is the maximum. So up to 300, you can take it along y-axis. Now, when you plot the total runoff hydrograph, so this will be the shape of the total runoff hydrograph. Now, you measure the ordinates of the total runoff hydrograph. That is, these are the vertical ordinates at different time interval of the total runoff ordinates. So that is the ordinates that you get here. So these are the ordinates of total runoff hydrograph, total runoff ordinates. So whatever the values that is in column 3, it is got by this one. So you have to measure the vertical height from this point at a regular time interval. You have to measure this one, this height. So this height is nothing but your total runoff ordinates. And if you separate the base flow, so these are the base flow ordinates. Whatever the base flow ordinates you can see here, from this point to this point, these are the base flow ordinates. So you'll get these ordinates of the total runoff ordinates and base flow ordinates when you plot the graph of discharge versus time with the following data. So now here you got the total runoff ordinates. These are the total runoff ordinates, and you can also measure the base flow ordinates. So whatever the values in column 4 are the base flow ordinates. So if you deduct the base flow ordinates from the total runoff ordinates, you will get the direct runoff ordinates, the DRO or nothing but the direct runoff ordinates. So this direct runoff ordinates has to be divided by, you can see here, P net. P net is nothing but sigma QT divided by A. So sigma QD is nothing but the sum of the direct runoff ordinates. So here you can see the sum of the direct runoff ordinates works out to be 986 cumex. So this 9 sigma QD direct runoff ordinates divided by the area of the catchment, that is 986 into the duration of the storm is 3 hours, 60 into 60 divided by the area of the catchment is 40 kilometers square. So you get the net precipitation depth as 26.6 centimeters or 0.266 meter. So now each of these direct runoff ordinates, whatever the direct runoff ordinates you got, it has to be divided by the net precipitation depth. It has to be divided by, these are the direct runoff ordinates. It has to be divided by the net precipitation depth. So net precipitation depth, we got it as 26.6 centimeter. Each of these ordinates of the direct runoff ordinates has to be divided by 26.6. So we get the ordinates of the unit hydrograph. So these are the ordinates of the unit hydrograph. Now, so once you get the ordinates of the unit hydrograph, now you can see here, start from the 5th hour. The unit hydrograph starts from the 5th hour. You can see here, 5th hour, the ordinates of the unit hydrograph starts. So hence, from 5th hour, so these are the ordinates of the unit hydrograph at different time intervals, so up to 33 hours. So this is the unit hydrograph which has been derived from the given observed flood hydrograph. So only thing is, first you have to plot the discharge versus time, a graph of discharge versus time. So you'll get the total runoff ordinates. So you measure the vertical the intercept of the total runoff ordinates will get. So that deducted by the base flow ordinates will get the direct runoff ordinates. So this direct runoff ordinates divided by the net precipitation depth will get the unit hydrograph ordinates. Now we want to cross check whether the unit hydrograph theory says that it produces a volume of runoff is equal to 1 centimeter. Now, if you add all the ordinates of the unit hydrograph, so now these are the ordinates of the unit hydrograph. That is, you take sigma UHO, that is ordinates of the unit hydrograph. So that divided by the area of the catchment, it should produce a volume of runoff is equal to 1 centimeter. It should produce a volume of runoff is equal to 1 centimeter. So that is the cross check that you need to make. So when you add the ordinates of the unit hydrograph, that is sigma unit hydrograph UHO ordinates, so that divided by the catchment area, that is 40 into 10 power 6, the amount of rain, that is the runoff volume, should be equal to 1 unit or 1 centimeter. So that is the cross check that you can make. So first, again, I will explain. So you have on 2 particular days, you have 2 storms. The duration of the storms is 3 hours, and you have been given with the discharge values. That is the problem here. You can see here. These are the discharge values are given on 2 particular dates, and the time interval is 3 hours. And this is the peak value of the discharge. So when you plot a graph of discharge versus time, so we get the ordinates, that is the total runoff hydrographs. So from this total runoff hydrographs, you have to find out the total runoff ordinates. So then you have to separate the base flow component. Then you have to find the base flow ordinates. So hence, total runoff ordinates minus base flow ordinates will get the direct runoff ordinates. Once you get the direct runoff ordinates, you have to divide it by the net precipitation depth in order to get the ordinates of the unit hydrograph. So once you get the unit hydrograph, you take the sum of the unit hydrograph ordinates, that divided by the area of the catchment. So it should produce the volume of runoff is equal to 1 centimeter. So that is the definition of the unit hydrograph. Now, so we shall solve some numerical problems on unit hydrograph. I think I have shared some of the problems in your WhatsApp group. The problems in Bandidia. Hello. WhatsApp group se problem in Bandidia.
Yes, sir.
Bandidia alva?
Yes, sir.
Now, next is, so far we have discussed what is a hydrograph, and also how to derive a unit hydrograph from the observed flood hydrograph. And we know how to derive a unit hydrograph from the observed flood hydrograph. Now, there are 2 cases. That is, one is changing a short duration unit hydrograph to a longer duration unit hydrograph. That means you can change a short duration unit hydrograph to a longer duration hydrograph, or vice versa, or else you can convert a longer duration unit hydrograph to a shorter duration, or you can change a shorter duration unit hydrograph to a longer duration. So now there are two cases. So let us discuss each one. So now case one, wherein changing a short duration unit hydrograph to a longer duration. So if the desired long duration of the unit hydrograph is an even multiple of the short, that means if you want to change a short duration unit hydrograph to a longer duration hydrograph, the longer duration hydrograph should be an even multiple of the shorter duration. That means if the desired long duration of the unit hydrograph is an even multiple of the short, say a 3-hour unit hydrograph is given and a 6-hour unit hydrograph is required. That means the longer duration unit hydrograph is an even multiple of the shorter duration. Now, we have to follow this procedure. Assume 2 consecutive unit storms. That means we have to assume 2 consecutive unit storms producing a net line of 1 centimeter. That means we have to select 2 consecutive lines which produces the volume of runoff is equal to 1 centimeter. Now draw 2 unit hydrographs. The second unit hydrograph being lagged by 3 hours. That means we are changing a short duration unit hydrograph to a longer duration unit hydrograph such that the longer duration unit hydrograph is a even multiple of the shorter duration. Now we have to assume 2 consecutive unit storms producing a net line of 1 centimeter each and draw the 2 corresponding unit hydrograph, and the second unit hydrograph is lagged by 3 hours because we require a 6-hour unit hydrograph from the given 3-hour unit hydrograph. So the lag time is about 3 hours. So hence the second unit hydrograph is being lagged by 3 hours. Now draw the combined unit hydrograph by the method of superposition. So in the last class we have discussed what is the how to combine the 2 unit hydrographs into a single unit hydrograph by the method of superposition. So this combined hydrograph will produce 2 centimeters in 6 hours because we have selected 2 consecutive unit storms producing a volume of runoff is equal to 1 centimeter each. So hence, these when you combine these 2 hydrographs, which will produce a volume of runoff is equal to 2 centimeters in a period of 6 hours. Now, to obtain the 6-hour unit hydrograph, divide the ordinates of the combined unit hydrograph by 2 because here the longer duration unit hydrograph is a even multiple of the shorter one. So first what you have to do is assume 2 consecutive unit storms which produces a net volume of runoff is equal to 1 centimeter each. Then draw the 2 unit hydrographs and the second being lagged by 3 hours. It has to be lagged by 3 hours. Now draw the combined hydrograph by the method of superposition, and this combined hydrograph will now produce 2 centimeters in 6 hours. Now to obtain a 6-hour unit hydrograph, because we are changing a short duration unit hydrograph to a longer duration hydrograph. So to obtain the 6-hour unit hydrograph, divide the ordinates of the combined hydrograph by 2. So then you will get the ordinates of the 6-hour unit hydrograph. So here, this is the case 1 wherein you can change a short duration unit hydrograph to a longer duration unit hydrograph. So the condition is the longer duration unit hydrograph should be a even multiple of the short duration hydrographs. So you have to select 2 consecutive storms producing a net volume of runoff is equal to 1 centimeter. Then draw the 2 unit hydrographs separately and then combine by the method of superposition. Then whatever the ordinates of this combined unit hydrograph has to be divided by 2 because it is an even multiple of the short duration hydrograph. So by this method you can derive a 6-hour unit hydrograph from the given 3-hour unit hydrograph. Or else you may have a 2-hour unit hydrograph, then you may require a 4-hour unit hydrograph such that the longer duration unit hydrograph should be a even multiple of the short duration. So this is one method by which you can change a short duration unit hydrograph to a long duration unit hydrograph. So now we shall work out a numerical problems on changing a short duration unit hydrograph to a long duration unit hydrograph. Now, the following are the ordinates of 3-hour unit hydrograph. Derive the ordinates of a 6-hour unit hydrograph and plot the same. So this is the given problem. Now here, I think the screen share is visible. Now here, you have the values. 3-hour unit hydrograph has been given to you. From this 3-hour unit hydrograph, you have to derive a 6-hour unit hydrograph. So now 0, 3, 6, 9, 12, 15, 18, 21, 24. And these are the 3-hour unit hydrograph ordinates in Cumex are given. That is 0, 1.5, 4.5, 8.6, 12.0, 9.4, 4.6, 2.3, and 0.8. So now here you have been given a 3-hour unit hydrograph and you require a 6-hour unit hydrograph. Now this is the solution, derivation of a 6-hour unit hydrograph of the given 3-hour unit hydrograph. So now in the first column, the time in hours, that is 0, 3, 6, 9 up to 27 or 24. Now the 3-hour unit hydrograph ordinates are given here. That is in Cumex. That is 2, 0, 1.5, the last being 0.8 at 24th hour. Now, 3-hour unit hydrograph lagged by 3 hours. That means you have to shift in column 3, you have to shift the values of column 3 by 3 hours. That means this is the starting 0. So here in the column 3, you have to shift by 3 hours because we require a long duration unit hydrograph, 6-hour unit hydrograph, so which is lagged by 3 hours. So in the column 3, whatever the column 3 values, that is nothing but the column 2 values has to be shifted by 3 hours. That is the lag time. That you can see here. This 0 is here. Like that, you have to shift these values by 3 hours. This is the lag time. Next, you add the ordinates of these two, that is 3-hour unit hydrograph and 3-hour unit hydrograph lagged. You can see here it's lagged by 3 hours. So you add the column 2 values and column 3 values, you will get the ordinates of the combined unit hydrograph. So these are the ordinates of the combined unit hydrograph. So this ordinates of these two combined unit hydrograph produces a volume of runoff is equal to 2 centimeter. Now, in order to get a 6-hour unit hydrograph, so you have to divide the ordinates of the combined unit hydrograph divided by 2, because the longer duration unit hydrograph is even multiple of the shorter duration. So hence it has to be divided by 2. So you get the ordinates of 6-hour unit hydrograph. So this is the method by which you can change a short duration unit hydrograph to a long duration unit hydrograph. That means the longer duration unit hydrograph is an even multiple of the shorter, and the 3-hour unit hydrograph is given, and you have to derive a 6-hour unit hydrograph. That means this 3-hour unit hydrograph has to be lagged by 3 hours, in order to get the 6-hour unit hydrograph. So any doubts with this problem? So these are the ordinates of 3-hour unit hydrograph. So you can derive the ordinates of a 6-hour unit hydrograph. Or else you may have ordinates of a 4-hour unit hydrograph, and you can derive a 8-hour unit hydrograph from the given 4-hour unit hydrograph ordinates. That means you have to lag it by 4 hours. So such that the longer duration unit hydrograph should be a even multiple of the short duration. Now that is case 1, wherein you have been given with a short duration unit hydrograph and you have changed the short duration unit hydrograph to a longer duration unit hydrograph, such that the longer duration unit hydrograph is an even multiple of the short duration. Now the second case, see, I don't know, here the participants are 40 and in the chat box 55 people have already marked their attendance in the chat box. ನನಗೆ ಗೊತ್ತಿದೆ ಹೆಂಗ್ ಆಟ ಆಡಬೇಕು ಅಂತ. ಹಲೋ, ನಿಮ್ಗೆ ಇಂಟ್ರೆಸ್ಟ್ ಇದ್ರೆ ಕ್ಲಾಸಿಗೆ ಬನ್ನಿ, ಸುಮ್ಮನೆ ಅಟೆಂಡೆನ್ಸ್ಗೋಸ್ಕರ ಬರಬೇಡಿ. or else I know I can also play the same trick with you all. Already chat box 55 ಜನ attendance ಹಾಕಿದ್ದಾರೆ, whereas the participants are only 40. ಕೆಲವರೆಲ್ಲ ಆಪ್ ಹೋಗಿದಾರ. Who is this Redmi? ಯಾರಿದ್ Redmi? ಹಲೋ, ಈ ತರ ಲಾಗಿನ್ ಆಗ್ಬೇಡಿ ಅಂತ ಹೇಳಿದೀನಿ ಸುಮಾರು ಸತಿ. ಇನ್ ಸ್ಪೈಟ್ ಆಫ್ ದಟ್ ಯಾರದು ರೆಡ್ಮಿ? Next is you can convert or change a long duration unit hydrograph to a shorter duration, or a shorter duration unit hydrograph to a longer duration, such that even the short duration hydrograph is not even multiple of the longer duration, or longer duration hydrograph is not even multiple of the short duration. So this can be done by using a technique known as S-curve technique. S-curve technique. Now you can see here, changing a long duration hydrograph to a short duration hydrograph, or the other way, or else you can even convert a longer duration to a shorter duration unit hydrograph, or a shorter duration unit hydrograph to a longer duration unit hydrograph. So by the method of S-curve technique, S-curve technique. So S-curve, or it's also called as the summation curve, is the hydrograph of direct surface runoff that would result from a continuous succession of unit storms producing 1 centimeter in TR hour. TR hour. That means by S-curve technique is nothing but it is the summation curve. Summation curve that is of direct surface runoff that has resulted from a continuous successions of unit storms which produces a volume of runoff is equal to 1 centimeter in TR hour. So now, if the time base of the unit hydrograph is T, so in the components of the unit hydrograph, the time base remains same for all unit storms, or the base width of the time base. So it reaches about a constant outflow at TR hour. Since 1 centimeter of net rain on the catchment is supplied and removed every TR hour, only T by TR unit graphs are necessary to produce an S-curve and develop constant outflow. That means, so we have selected here, you can see the graph of the figure of the S-curve. Here, you can see here, you have successions of unit storms, continuous unit storms, that is 1, 2, 3, 4, 5, 6, which produces a volume of runoff is equal to 1 centimeter. 1 centimeter. So now, when you plot the graph of this hydrograph, which has resulted from the succession of unit storms, which produces a volume of runoff is equal to 1 centimeter. Now, you have to shift this curve. You have to shift this curve. Now you can see here all these unit storms which produces a constant volume of runoff, constant volume of runoff. So that means it will have a constant outflow. So it is given by the formula, that is the constant outflow formula is nothing but 2.7 times A divided by the TR is nothing but the duration of the storm. It is 1 hour, or it may be 2 hours or 3 hours. So you have to find this constant volume of runoff that is given by the equation 2.78 times A divided by TR. Now, if you have a continuous unit storms which produces a volume of runoff is equal to 1 centimeter. So now this is the curve you get. Now this is the curve you get, and finally it will produce a constant volume of runoff. You can see here constant outflow QT is equal to 2.7 times A divided by the time divided by time in hours. Now, this curve is in the form of shape of S curve. So it is called as a S curve. So now we can change a short duration unit hydrograph to a longer duration unit hydrograph, or a longer duration unit hydrograph to a shorter duration hydrograph by the method of S curve. Now here, in order to derive a short duration unit hydrograph to a longer duration, or a longer duration unit hydrograph to a short duration, first you have to plot this S curve. First you have to plot this S curve. So once you plot this S curve, and this S curve is shifted along time axis, whether you require a 3-hour unit hydrograph, or a 6-hour unit hydrograph, or a 7-hour unit hydrograph. So based on the time scale, you have to shift this S curve along the time axis. Now the S curve has been shifted here. Correct? Now you have to find the difference of this S curve, two S curve ordinates. So two S curve ordinates. So thereby you can shift a short duration unit hydrograph to a longer duration unit hydrograph, or a longer duration unit hydrograph to a shorter unit hydrograph. So we shall discuss numerical problems on the S curve. So in the examination, you may have problem of this kind, wherein you can change a short duration unit hydrograph to a long duration unit hydrograph, such that the longer duration is even multiple of the short duration. Or you may have problems on S curve technique, wherein you can change a long duration unit hydrograph to a short duration hydrograph, or a short duration hydrograph to a longer duration hydrograph, such that the longer or shorter duration hydrograph is not even multiple of the longer or shorter, either way. So this can be done by using the S curve technique. Anyway, the time is running out. So all of you mark your attendance in the chat box. If you are not marked, please mark your attendance in the chat box. So nimdu IA marks ella ನಾನು ಅಪ್ಲೋಡ್ ಮಾಡಿದ್ದೀನಿ ಜಾಮ್ಸ್ ಅಲ್ಲಿ ಬಂದಿದೆಯಾ? ಸುಮಾರು ಜನ ಪ್ರಾಬ್ಲಮ್ಸ್ ತಪ್ಪು ಮಾಡಿದಿರಿ. ಕನ್ಸಂಪ್ಟಿವ್ ಯೂಸ್ ಪ್ರಾಬ್ಲಮ್ ಇತ್ತು, ಅದನ್ನು ತಪ್ಪು ಮಾಡಿದಿರಿ. ಸೊ optimum number of rain gauges minimum problem ittu. You have done some mistake. I think all of you have received your marks. Also, I have uploaded in the jams. You can see your marks, and if you have any clarification, let me know. Anyway, mark your attendance in the chat box. I'll be ending the session. ಎರಡೆರಡು ಸತಿ ಅಟೆಂಡೆನ್ಸ್ ಮಾರ್ಕ್ ಮಾಡಬೇಡಿ ಪ್ಲೀಸ್. ಕೆಲವು ಎರಡೆರಡು ಸತಿ ಮೂರು ಸತಿ ಎಲ್ಲ ಮಾಡಿದಿರಿ. So I will be ending the session.